In this video, we are going to discuss the architecture of our application and the important role that the dispatcher is going to play. So we haven't talked about what the dispatcher is or what it does. So I want to take a step back. I threw up a really crude sort of outline of how the data will flow to and from our DOM, our view, our browser, and the server. So basically what a dispatcher is, all it is it's a object that you can subscribe to events from and then publish events to. And that's really all it is. And so it just contains a list of subscriptions. The dispatcher we are going to write is going to have a couple of convenience methods on it, but overall it is going to be used both on the server and on the client as sort of an event bus. And it dispatches actions. What is an action? Well, an action is just a JavaScript object with a property called type and potentially a property called status. So an action just describes that either you want to do something or something was done. So we'll be using actions throughout. There are just simple JavaScript objects with a type property. The type of the action determines, well, the type of the action. Are you logging in? Are you opening a dialog? Are you doing any sort of particular interaction with the program? So the architecture that I came up with is very similar to Flux, the Flux architecture that you can read about on in the React documentation, and also takes some inspiration from Redux, which is another architecture that's definitely worth taking a look at. But the architecture that we are going to be using, while similar in concepts to both Flux and Redux, takes advantage of reactive extensions. So let's talk about this diagram. First of all, you have this big dispatcher guy here. He gets actions, and then once he gets an action, he dispatches an action to whoever's listening for that action. The only things that are going to be listening for actions, however, are the stores. And what the stores are going to be, there'll be a lobby store, a game store, a user store, an app store, and so on. And what they do is they subscribe to the dispatcher, receive actions, and then they publish reactive extensions, RxJS observables that can be listened to from your containers. So the store is just going to be they're just going to be a couple classes. They listen to actions and then they publish reactive extension observables that can be subscribed to. Then you have containers. Now, what are containers? Containers are components that interact directly with both the dispatcher and the stores. So a container is going to both do two things. It's going to subscribe to the stores to listen to changes from the app state, and it will also have callbacks that will then turn the intent of the user. Let's say you type in a message and hit enter, and a send message action or a send message callback from the chat component gets sent to the lobby container. It'll then take that intent, turn it into an action, send it to the dispatcher. So let's follow through an example of, like I just said, sending a chat message. All right, so we have these. I have subcomponents over here. Subcomponents are just the standard components that we're going to be writing. Things like the chat box, for example, is like a subcomponent. It doesn't directly interact with or know about things like stores or actions or socket.io. It's completely isolated, and that's really how most things should be. So you have your chat list. It's a subcomponent. And then the user hits enter, and it will then invoke a callback saying, hey, the user wants to send a message. That'll be then sent to its container. And in this case, it's going to be either the game container or the lobby container. And the lobby container or the game container is going to receive that intent, that callback, and then it's going to dispatch an action to the dispatcher and say, hey, dispatcher, the user wants to do something, go do it. And in this case, it'll be like a send lobby chat message action or a send a game chat message action. And then the dispatcher is then going to receive that action and notify anybody who's subscribed, any store that's subscribed to that action action was performed. So in this case, maybe the lobby store receives the action saying the user wants to send a message to the lobby. And so now the action is finally in the store. Now the stores they are the model, they are the business logic of the application. They can do a variety of different things. they can just ignore the action if they wanted to, but then nothing happens. They can submit a AJAX request, an XHR request to a web service. They can just shoot that action straight to the server via socket.io if they wanted to. And that's mostly what's going to be the case. They can also do validation, saying, hey, your message is too long. I already know the server is going to reject this action. So I'm going to say that this action was rejected, which will result in another action dispatch, which will then go back to the store, and then the store will update its observable. But let's say that validation passed. So then the store will send that action directly over socket.io to the server, and the server is just a black box here. It'll just do whatever, or perform whatever logic that you want to put in the server. And then the server can decide to accept the action, reject the action, or perform something. Perform an operation. And performing that operation, such as sending a chat message to the lobby, might result in another action being generated by the server saying, hey, there's a new message in the lobby. So then the server, through socket.io, will be hooked up directly to our dispatcher saying a chat message was added. And then the dispatcher will then, of course, let everybody who's subscribed to that dispatcher, it'll let them know that that message was accepted and it was indeed added. And then the dispatcher will tell the lobby store, hey, this chat message was added. Go ahead and update your subscriptions. And then reactive extensions, the way we'll be setting up our observables, will then be then publish that data, which will then, because the containers are subscribed to the observables, the container components will then be updated. Basically, the container components will subscribe to the observables, and anytime new data comes in, it will then invoke set state on the component. And of course, invoking set state on a component results in a re-render. And then, because it has that new data now that was sent from the observable, it will then re-render and pass that new data along with the props of its subcomponents. In this case, the messages property on the chat component. And it's okay if this diagram doesn't quite make sense yet. This is just a high-level overview so that I can describe what the dispatcher is and does, and some of the terminology we're going to work with, such as actions, types, statuses, and so on. Because in the next video, we're going to be writing our dispatcher. We're not going to use all of the functionality of it just yet in this course, but it'll be there for us to use later. So again, this is a sort of unidirectional data flow. You can think of basically it goes to a callback, goes to an action, goes to a store does something, results in another action being sent to the dispatcher, going back to the store to an RxJS subscription into a container back to the subcomponents. And it might look unnecessarily complicated, but there is absolutely a reason why this style of architecture, which again shares similarities with both Flux and Redux, is beneficial. And I think that you will see as we start putting together our stores and our containers that that things really come together very nicely in a very clean way, where we control all of our state in isolated locations. This is the absolute pinnacle of separation of concerns, allowing us to keep our business logic in our stores and keep our subcomponents and even our containers very small and simple and straightforward. And it really does increase the maintainability and readability of your code. But yeah, I sort of debated on whether or not I would show this slide before or after we actually implement our first store and our first observable, but I decided it was a good idea just to introduce the terminology, even if you might have a hard time visualizing how this will appear in code. Maybe we'll come back to this slide after we have a proper example set up. But yeah, at the end of the day, the stores that's the business logic. That's where the validation can occur. That's where it sends information back to socket.io to the server. That's where the observables are created. In a Redux sort of sense, Redux has generally one store, or it always has one store, and has reducers and middleware. And you can apply the concept of a single store reducers and middleware somewhat to this diagram, or to this architecture. But the most important thing is to understand the basic concepts of how actions are dispatched. And once you understand that, once you get kind of into the flow of doing things like this, no matter if you're using this architecture, Flux or Redux, it doesn't matter, because the concepts, although the implementation varies, the concepts are very similar and translate very well to each other. And with that, we will leave this video. In the next video, we will be writing the dispatcher, which will be a very, very important piece of code. And we'll see you guys in the next video.